All right, so this video is basically, I'm calling it the empirical rule breakdown. Because what happens is that there's obviously some pieces where if you search further, which I ask you not to, if you search further about the empirical rule, you'll find out that there is more than just those three magic numbers. And sorry, I'm fighting with my pen here. So there's the empirical rule breaks down the three magic numbers. That's 68, 95, and 99.7. I apologize for my childish handwriting. I'm getting used to using the pen again here, so I'm just kind of struggling a little bit. So, but with that said, so here are my three numbers: 68, 95, 99.7. And so, I could make a 15-minute video that talks about how those numbers break down. What I'm going to do is I'm going to hand this image to you, and I'm going to ask you to take these numbers and to add them to your standard normal distribution drawing that you have in your notes, and to reference this. And then I'm going to answer some questions, or I'm going to work through the questions that they've discussed with you, because when they explained it in Hawks, they went more so in a route where they're using z-scores to help you understand. And so I'm going to go straight to the idea of, hey, these are the percentages. So here's the one main one I'm going to talk about here to break down, and that is, we know that between this guy right here and this guy right here, so from this spot right there and this spot right here, on a normal distribution, we know that that's 68% of this entire picture. So this entire picture would be 100%, right? So if we go from the very end over here to the very end over here, that would represent 100%. So we know that 68% is going to be that area right smack in the middle. And so why 34%? Well, if we take 68 and we cut it in half, so we take the 68%, we cut it in half of that is 34. So what we're saying is, if we take this and cut it right smack in half, then 34% of it's going to be over there, and 34% is going to be over there. Okay, moving along. I'm going to do it one more time. So how do we arrive at 95%? Well, we know inside this white area that's 68%. We know that 95% is 2 standard deviations, so it goes between those two lines. So we know that all of this that I'm highlighting here in blue, we know that all of this represents 95% of this entire normal distribution, of our entire set of data. So if we break that down and we think about it, okay, well, we already used 68%. The white or the purple here that I've already kind of drawn on, that's 68%. If we add on these two little green wings on either side, that adds on some more. Well, how much more? Where did that 13.5 come from? Well, leftovers. We got 95%. We take away the 68%. So we have the 95% from here to there. That's 95. We take away what's in the middle here, the 68, and we find out that we're left with, let's see, 27. Fighting a little bit of glare. So I end up with 27%. Well, 27% is what's split between this green sliver and that green sliver. So we take that 27%, we cut it in half, and we get 13.5%. So that's where the 13.5's come from. So this is where I'm going to stop with this explanation. Like I said, I could record a 15-minute video explaining to you where those percentages come from and how to utilize them. But instead, what I'm doing is I'm handing you this picture. I'm giving you this picture and say, use this picture to solve this problem. Trust me, that little percentage, that orange sliver right there is 2.35%. That little orange sliver right there is 2.35. And then the last one to trust me on is that there's a little bit left over right here. There's a little bit, and that little bit that goes right there is 0.15%. 0.15%. So hardly anything. And same thing over here. So we got a little sliver right there. Okay, of 0.15%. Now, I'm going to hit pause for a minute on my video, and I'm going to move some stuff around and kind of pick back up my comment. All right, so I'm back. And all I've done is I have my previous slide here where I explain my percentages to you, and I've just recreated the slide so we have it up here for us to talk about and to work off of. Okay, so now the way that I recommend you approaching this question is I recommend you starting off, and I'll tell you what, let me tuck this thing off on the side over here. And let me tell you how I would do this. So I would start off here and I would draw myself a line. And this line is the beginning of my normal distribution. I draw a little spot in the middle. And I know that little spot in the middle represents my mean. So I know that my mean is 3,000. And then I know that I'm making a normal distribution. I go out 1, 2, 3 lines, and then I come down 1, 2, 3 lines. And those lines represent +1 standard deviation, +2 standard deviations, +3 standard deviations. Or if I go the other way, that represents -1 standard deviation, -2 standard deviation, and -3 standard deviation. And right, with the mean being right smack in the middle. Okay, so with that said, here I am. I've set up. I begin the process of what do these numbers mean. Okay, well, I still don't have what data is represented by 1 standard deviation, what data is represented by 2 standard deviations. So now I need to take that into consideration. So my standard deviation is 500. So that means that if I want to go from my mean of 3,000, I want to go up 1 standard deviation. That's going to put me at 3,500. If I go up another standard deviation, that will put me at 4,000. If I go up another standard deviation, that will put me at 4,500. If I go down from the mean, I take away 1 standard deviation, that puts me at 2,500. I go down another one, that puts me at 2,000. I go down one more, and that puts me at 1,500 for standard deviation. Let me clean that up just a touch. That's like 1,560. So this is my process that I go through when I'm going to work on these questions, because now what I do is I take this picture, I take these percentages, and I'm going to put them on top. I'm going to identify what I know. So I put my little normal curve on top so I can fill it in with percentages. Draw my little lines in. And obviously you can use your 95, you can use your 68 and your 99.7. You can use those numbers. But we can just as easily put in these percentages. So if you want to know the percentage between 2,000 and 4,000, so we've got our 2,000 right here, we got our 4,000 right here, we can take our percentages and fill them in. That sliver right there is 13.5, that sliver right there is 34, 34, 13.5. So first of all, we know that that's 2 standard deviations, 2 standard deviations, that's 95%. If we take our calculator, I'm going to hit pause real quick, get my calculator out. Okay, so we take our calculator, we pull it out, we plug in those numbers. So 13.5 plus 34 plus 34 plus 13.5, go, we get 95%. So the area from this guy to this guy, which we already knew because of the empirical rule, says that's 95%. But that's kind of reconfirming for you where are these numbers coming from. All right, so I'm going to hit pause real quick, clean myself up, we'll do part 2. All right, so part 2. We're basically looking at the same curve. I don't have to change anything on the bottom. I still got these numbers on the bottom, but now I'm looking for the area less than 3,500. So here's 3,500, right? That line right there. So I'm looking for the area less than 3,500. So I basically, utilizing this little tool right here, this little normal distribution curve that I've provided for you with these percentages broke down for you, I can just fill in what I need to know. So I got a 34, I got a 34, a 13.5, a 2.35, and a 0.15. Take my calculator out and start adding those up. So I'm going to do 34 and 34, that's 68. 13.5, 2.35, and 0.15. So that gives me a total of 84%. So if I'm looking at, and remember, that's the green area, that's 34 and 34, that's 68, 13.5, 2.35, and 0.15 gives me 84%, whereas this one was 95. So let's play around with this a little bit. And let's go ahead and answer the last questions that are here. So then what range is in the middle 68? Well, the middle 68 would be, that's 1 standard deviation to 1 standard deviation, so that's 2,500 to 3,500. But let's let's play around. What if I threw another one on here, and what if I was looking for it to be greater than 4,000? So what if I was looking for it to be greater than 4,000? So there's 4,000 right there. So if I want to be greater than 4,000, that means I'm looking for those two slivers right there. I come over to our chart. That sliver right here is 2.35. That last little sliver is 0.15. So we pull out our calculator. We got 2.35 plus 0.15. Go, and we get 2.5. So if you were greater than, you'd be looking at 2.5%. And you can play that game any way you want to. Now that you know which percentages go in each one of those little slivers that can be created by the empirical rule, then you just figure out what two boundaries, whether it be 2,000 and 4,000, whether it be 4,000 and greater, whether it be 2,000 and less, whatever combination, you can then use the empirical rule to find the percentages under the normal distribution. Hopefully this gives you a good head start on that. Please take your time, listen to each part as needed, review, and send me any questions.